All right, ladies and gentlemen, boys and girls, we're good to go here. We're doing StereoKit, a code-first approach to mixed reality development. We've got Nick Klingensmith, Mixed Reality Academy lead engineer at Microsoft. Let's give him a big round of applause. Welcome, Nick. And it's all yours.
Can you? Yeah, okay, cool. So, hello, welcome. I'm here today to talk about StereoKit. I am Nick Klingensmith. I am the Mixed Reality Academy lead engineer here in San Francisco. So, I do a lot of events, I make a lot of tools, I talk to people. But StereoKit has been a project that I've been working on for the last 2 or so years, and I'm excited to share it with you some. So, first of all, you might have seen a little bit of a blurb about this, but I'm going to tell you a little bit more. So, StereoKit is a mixed reality engine or library. This is C#, and it's kind of like built into everything that you expect from a normal C# application. Like it's distributed through NuGet, and it behaves like a normal C# library. It's also code first. So if you are a programmer, this is something that you'll feel really comfortable with. Hopefully that didn't scare all of you off. I assume that you're here because that didn't scare you. But it's code first, and one of the nice things about being code first is that you can kind of treat that code like the user experience. So I kind of do some stuff like that where the code is the user experience. It's nice to work with. But just to see it in action here, this is kind of a little bit of a demo reel of that I did for one of the recent releases. And this kind of shows you what you can do with StereoKit. The concept is if you are building mixed reality applications from scratch. Like, if you went without any sort of game engine, without any sort of rendering libraries or whatever, like, it does all of that stuff for you. And it does it itself. It's lightweight. It's its own renderer. I actually, like, a while back, I looked at C# and I was like, okay, what does it take to draw something three-dimensional with C#? I came back from XNA. I used to do a lot of XNA way back when that was still a relevant thing. Yeah, XNA. It was a beautiful library. I loved it. But it's gone now. And it was kind of sort of replaced by Monogame. That was kind of the alternative to it. And Monogame is kind of built on top of deprecated libraries. So it was kind of like, okay, that's kind of a concerning state. And like, what can I use that's trustworthy? And there wasn't really a whole lot. There's nothing first party for sure. You basically had to go to the source. So StereoKit is its own renderer. This goes all the way down to native code and renders in DirectX and OpenGL and stuff like that. So it takes care of the rendering stuff for you. Now, the big thing that actually makes StereoKit possible is OpenXR. OpenXR is something I was quite excited about. I saw it and I was like, this is great. This is going to save me a whole lot of work. I took out OpenXR and it's the foundation for StereoKit. Anywhere that OpenXR works, StereoKit should work. I've spent a lot of time making sure that this library is cross-platform. Works on Windows, it works on Android, it works on Linux. I don't have macOS support yet, but macOS doesn't actually have mixed reality hardware. I'll talk about phones in a minute there because that is kind of an interesting caveat. But all of these platforms you see here, StereoKit works on right out of the box. It's pretty great. Now, OpenXR was also kind of the inspiration for StereoKit initially. So Microsoft, a long while ago, we released a 0.9 version of OpenXR. This was like a little bit before the full thing came out. And at the time, I was writing native tutorials for Azure Connect, or Connect for Azure. And so I was deep into native code at the time, and I was like, I'm going to write a tutorial for OpenXR. Like, this is going to be great. This looks like fun. And so I built the shortest piece of code that I could write for OpenXR. It was about 700 lines of code, and it included OpenXR code and some DirectX code and application code. And you can see the result here. Not a super complicated thing, but this was completely from scratch with its own renderer and everything. And that was 700 lines of code. But the part that really, really blew me away with this experience was the fact that this could deploy to a HoloLens in 5 seconds. I don't know how many of you have done a lot of deploying to HoloLenses before, but that is a life-changing number. 5 seconds from build to deploy to see it on your HoloLens. It was so good. And like this was a big enough deal for me that this is what inspired StereoKit. I was like, I'm going to build a whole thing on top of this idea because that 5 seconds is really valuable to me. Now, StereoKit doesn't quite do 5 seconds anymore. Like this was 700 lines of code, and StereoKit is a little bit bigger, but it is definitely sub-minute and can be quite faster than that in a lot of cases. So that's really, really good. I'm very excited about deploy times here. OK, so the other thing, too, when you are saying, I'm going to make a mixed reality engine, this is kind of a big thing to say, right? Like, that's a lot of different stuff. And if you look at the competitors in this space, the tools that people primarily use for building mixed reality applications, these tools have lots of features. So I kind of had to sit down and scope it and say, what can I do that is meaningful to developers? What can I scope this into that is achievable, yet still productive to be working on? Yeah, I don't have a whole lot of resources. It's mostly me and a bunch of community people, a couple of people inside of Microsoft here and there. So it's not a huge amount of resources, and I had to make something really good. So I focused on mixed reality. So like this is specifically for mixed reality. It doesn't do flat screen applications. You can do some debug development in flat screen applications, but this is mixed reality. On top of that, it is focused towards mixed reality headsets and not phone mixed reality. First thing there, OpenXR doesn't run on phones. If it did, I might reconsider that position, but that's a big time investment. I also kind of view phones as like a stepping stone to headset AR. I think our future is going to be in headset AR, so it's a little bit of a future-looking thought, but I think this is still a solid foundation to help scope things down appropriately. So then inside of StereoKit, everything is kind of designed with this mixed reality interface, these volumetric sort of elements, these hands, and the environment. I have interactions built into StereoKit. So like here on the left, you can see this is kind of a two-handed grab handle sort of thing. This is like 5 lines of code, one or two for the handle, one for drawing the model, one for drawing the box. Like it's super short, but it's easily composable. It's really easy to do, and it's just built in. Very simple stuff. On the right there, this is a GLTF model with a little bit of data on it that allows me to embed StereoKit's user interface onto the model surface. Like it's nice to have kind of those panel sort of UIs, but I think one of the nice things about mixed reality is that you can do some of this more volumetric or object-based interfaces. It's a little more exciting, and so I made sure that that was something you could do pretty easily. And then if you're working with mixed reality, you kind of need to have easy access to mixed reality APIs. So all of these things are really simple to do. Like this is eye tracking in the bottom left corner. It's input.eyes, and you get array. Like up in the top right, there's some world recognition, scene understanding stuff. This is world.enable occlusion. You give it a material of whatever type you want. Bottom right is kind of that world or scene understanding with some lighting applying to the world itself. It's a little bit of a faint pink glow, but you can see it there. And then, QR codes, anchors, stuff like that. So like all of these things are really easy to access inside of StereoKit. Like they're part of the core API. Like they're not extensions. They're stuff that you can just grab and go do things with. Make this easy for you, right? The other thing here that I do, kind of also a future-looking idea, StereoKit always has access to articulated hands. At every single point, you've got completely articulated hand data coming into the system. So like over there on the right side, when you are doing development with the flat screen interface, when you have your mouse on screen, it simulates a hand from that mouse. It'll animate between a couple of different poses based on what buttons you're pressing. Similarly, over here on the left side with controllers, any sort of VR controller is going to simulate hands based off of your button presses. So these behave like articulated hands. You can write code for articulated hands. And when you get into a device that does real tracking of your hands, then all your code still works. So like in the middle, this is the Leap motion controller. I've got one of those glued to my headset. It's what I do most of my development on. But this also works with like the HoloLens hand tracking as well as the Quest hand tracking. Like this is super great. Like one of the great things about the future is that we've all got hands. A lot of headsets are going to be doing hand tracking. I came up with this idea 2 years ago. Like hands are the future of interaction. I'm happy to see that this is kind of being doubled down on with a lot of manufacturers. Like a lot of people are shipping with hand tracking and headsets now. So this is something that is coming true. Like you can't lose your hands. Your hands never run out of batteries. You're not going to drop them in the couch. You're always going to have access to some sort of hands. And so this is kind of like how I envision the future of interaction to be. So you always got hands. Hands are good. The next thing, keep it simple. So it's one of the things that I really wanted to do was enable people who are not game developers, who are not familiar with three-dimensional graphics, to dive into this library and make something with mixed reality without having to learn too much complicated stuff. So throughout the entire API, I say, like, let me keep this really easy. And so all of the APIs are like one line of code or maybe 2 lines of code. Up here, this top section, you don't need to read this code, I promise. This top section is the entire application that you see on the top right there. Like it loads a GLTF from file, it lets you walk around, you get hands. That's the whole thing. Like that's the entire application. One little file. Then down here, the user interface, that window that you're seeing right there, that's just these 5 lines of code. Like it's really simple. UI.button. If UI.button, exit. Like can't get easier than that. So this is kind of what I tried to do throughout StereoKit's API. One of the nice things about keeping your API simple like this is that you can describe objects really quickly. So like this is a little bit small, don't read it, but this code right here is basically the code for that ruler. So you can take this code, you can copy it, you can paste it, you could send it to a coworker. You could find this on a forum, paste it into your own application. Like the nice thing about this, there's no scene, there's no hierarchies, there's no components that you have to copy values in and out of, or like build connections. This is the entire ruler right there. So when you have a nice terse API, you can start building your code in ways where the code is the object, and it makes it really easy to manage, all in one place, all really simple. Along with simple, even with the simplest APIs, there are still complicated parts. And so StereoKit has documentation at its core. Like this is a core feature of StereoKit. The demo project that I write, where I do all of my testing, all of my unit tests, all of my development, it is, I have a markup format where I can embed comments in it. And when I build the final version of the project, the NuGet package, it scrapes through that entire document, copies that live code, generates screenshots, wraps that all up, and builds a documentation website. So all of the code that you see on the website is live code, guaranteed to compile. All of the screenshots that you see there are from the latest version. Those never go out of date. So this makes it really easy for me to write documentation and maintain documentation. I could do a presentation on this subject all alone. I really love this style of documentation. And I think you'll find this to be very valuable if you do start developing with StereoKit. Then occasionally, once in a while, I'll publish little demos like this. This was the release notes for 031 not so long ago, where I basically went through all the new features, and I just wrote a small scene for each one of them to show how it was used. This is an open source project. It's up on GitHub. You can go look at it and see how I did it. And it just goes through the whole thing, shows you, and that's that. It's really nice. A lot of people have looked at it and said, like, oh, it's really cool to see all this stuff in one place. So I try to do stuff like this every once in a while. The other thing is it has to be fun, OK? So like, this is mixed reality, right? If you're doing mixed reality code and you're not enjoying yourself, then something is seriously wrong. Like, this is what I encountered in the past. Like, I remember doing 3-hour build times, and oh man, like, mixed reality is cool. You got to be having fun with this. And so this is kind of like my weather vane for like, am I doing it right? Well, I'm having fun, so I must be doing something all right. And I do all sorts of fun things with StereoKit. Like I do little demos and experiments and projects, like constructive solid geometry things, like little user experience demos. Here's a little skinned animation poser. I like generating terrain. It's a bad habit of mine. Stuff like this. I just have fun with this. StereoKit is pleasant to use, and I think you'll find a lot of joy when you use it yourself. And the other thing here, a lot of tools in the mixed reality space are from the games industry. I like games. I'm actually from the games industry myself. But one of the things that I really, really also like building is tools. and applications too. Like, I think there's a lot of space in the mixed reality environment for regular content creation tools or applications, and this may be a little bit of an underserved market. So StereoKit is built in a way where it does prioritize non-game sort of things. And I think one of the things that I like to highlight here that illustrates this really well, StereoKit has a built-in file picker. So you know, what you're seeing with this one right here, this is kind of the fallback file picker. Sometimes the operating system will provide one. But this is like a default fallback file picker that'll just let you load up an object at runtime. So like in a lot of game engines, you often have to take your assets and compile them in advance. You know, there's all sorts of optimizations that get done. StereoKit's asset pipeline is at runtime. The file picker is one line of code. So you can take an asset that most users are likely to have, and you can load it up into StereoKit without having to worry about writing your own loader or you know, whatever. Like you can grab it from a URL and load it straight into your application. It's really great. Along with that, the tutorial project that I like to point people towards, this is StereoKit Inc. And this is basically like a mini content creation application. It's basically like a little painting thing. But what I did is, this is about 300 lines of code. Like the whole application, it does like painting, it has brushes. You can save it to file, you can load it from file, there's undo, redo. It's really basic, but it's 300 lines of code and it's well documented. Like this is kind of what I want to see people create with StereoKit, is this type of like content creation tool or application. You know, so that's why I made it the core of the tutorial sort of system. Trivial UI create. So you saw the UI stuff that I had there, like that really short little piece there. So I have a lot of different UI stuff that you can make. Like while there's kind of like the regular panels that are built in, there's also a lot of tools for customizing your own user interface elements. You can get a fair bit of customization out of the look and feel of this. You can replace all the models and the colors and stuff like that. Like in the bottom right there, you can use some of these user interface primitives to create your own user interface elements. I've also got full Unicode support. This was something I was very happy about. So like down in the bottom left there, you can see I'm actually typing Cyrillic into there, and it drops those Cyrillic characters into the font sheet. Like this works with Japanese, and that's kind of what I was really going for. I wanted it to be able to do a language as large and complicated as Japanese without the developer having to think about it. You don't have to build an atlas. You don't have to ship that atlas with you. You know, no megabytes of font atlas stuff hanging around. It just renders this on the fly and generates the font data for you. So this is really, really nice for some localization stuff. Very cool. And then kind of along with some of that custom UI, this is a small game that I worked on for a little bit. It's kind of like a dodging game. It's a little bit of a shaky footage. But this is basically a level editor that I built using all the different UI customization elements. And I put together, you know, you can just assemble these obstacles. You can put lighting in the scenes. It's kind of basic, but this was a day's work. You know, imagine with like a couple of extra days what this could look like afterwards. Like it gives you a lot of power to build things pretty quickly. I don't actually know where the radio is here. OK, performance by default. So one really tricky thing with mixed reality is that you're rendering lots and lots of pixels, and you're doing it with mobile hardware, and then you're doing it to 2 screens. This is a lot of work. And well, honestly, I've been doing graphics for a long while, so I'm very pleased with the performance of these devices. But you still can't be doing silly stuff. And when it comes to a lot of game engines, they may not necessarily be tuned for this type of device. You know, the HoloLens is a mobile headset. It's got a good chip, but it's still thermally constrained. It's still power constrained, and it is doing a lot of work. So you really have to have good defaults in order to be hitting your performance targets nicely. So I have a built-in physically based rendering shading pipeline. It works. It's designed for mobile. It's very, very fast. The default shader that, if you don't need a reflection or anything like that, is even faster than this. StereoKit is very, very good at rendering, and I have a very, very difficult time trying to drop frames with StereoKit. So this is a really great place to be at. Like, you don't have to hunt for the single passed instance, or how do I instance this, or which shaders should I be using here. StereoKit's defaults are all going to work really, really well for you. Now, kind of along with that, I did the lighting system within StereoKit is actually kind of interesting. Because this is not games focused, I took a step back with the lighting system and simplified it. So StereoKit doesn't actually have dynamic lights. What it has instead is spherical harmonics, which is basically like a little math representation of the lighting of your environment. So you can either like bake some lights together and get one spherical harmonic like this, or you can import like a cube map and get your lighting from that. But basically, it's really nice. It's a clean sort of lighting. It allows you to make something that looks really good, but is also incredibly fast. So you can get good-looking lighting at a very, very cheap cost. Now, you can do some dynamic lighting if you want to. There's like the shader system and rendering system is flexible enough for you to insert that stuff on your own. But by default, StereoKit kind of discourages like complex lighting because that's one of those places where you can get yourself in trouble really easily. OK, cool. Hopefully that's kind of interesting to you. So where do you get started with this? So the first thing, this ships on NuGet. This is regular C# stuff. I have a Visual Studio template, or Visual Studio extension, that gives you a couple of StereoKit templates. Those templates will get you started with a Hello World application right out of the box. It's my recommended route. Get the template, start up a Hello StereoKit application, and go from there. There's also a GitHub repository. This is completely open source. This is MIT licensed. You have access to the whole thing. You can fork it and make it your own if you want to. I don't recommend doing much with the GitHub if you're trying to do this as an end user, but if you want to make modifications to the engine itself, it's there for you to do, which is kind of cool. Also, if you want to debug stuff, sometimes that's really nice to have access to the source. StereoKit.net is the website. This is the documentation site that I was talking about. It's generated. It's awesome. The StereoKit tutorial, this is the StereoKit Inc. that I was talking about. That's also a GitHub repository. So you can grab that, look at it, have fun with it. And I've also got like a little Bing Maps demo. It just kind of downloads some terrain from Bing Maps and goes from there. And that's it. So I'm on Twitter. I post a lot about StereoKit on Twitter, so if you're like interested in where it's going or what I'm doing with it, that's the place to be. There's a couple of links down here. We are actually doing a StereoKit hackathon during the month of November here, so if that's something that's appealing to you, there's like about $6,000 of cash prizes, so it can be kind of cool. Runs till like the end of the month. And I recently added animation. That's kind of why I was showing that. This was the 034 update, skeletal and skinned animation. But yeah. Hopefully that's appealing and interesting, and I might have some time for questions.
Awesome, Nick. Thank you. Let's give it up for Nick. We do have time for questions, yeah? I don't even code, and I want to play around with StereoKit. That looks awesome. Do we have time for one or two questions here? We got someone here?
Yeah.
Thank you, Francisco Ortega, Colorado State University. Mm-hmm. Thank you so much. Thank you for mentioning XNA. I was sad when I was killed, XNA. So, two quick questions. One of them is, in the website says Oculus support. Does that include Oculus 2, I guess?
Yes, StereoKit does work on Oculus Quest. It is a little bit trickier than doing desktop or HoloLens because it requires Xamarin, but I do have support for that.
And the other question, and I don't know if you have an answer for this, but do you think that Microsoft will support this to get StereoKit maybe to continue the life of StereoKit?
Yeah, I do believe this is something that, like right now, one of the things that we're doing with the StereoKit hack is we're getting a lot of feedback from users to see how they use it, what type of interest that they have in it. So we're kind of in the early phases of that, but this is something that I hope to see adopted strongly, yes.
Any other questions here? We got one over there, all right. Come on over to you.
Are you using signed distance functions for your text rendering?
I'm not actually. I've not found it to be critical. I do have some kind of complex features for doing text rendering, make it look nicer. I do have plans to do signed distance field rendering in the future, but right now, one of the things that I do with the Unicode rendering is that anytime it sees a completely new glyph, it will render that onto the atlas, same frame, so there's no delay in it appearing. And so signed distance field text atlas can be a little bit pricey. It's a work in progress there, but it'll get there. It still looks good as it is.
And if I can ask one more follow-up, Do you have plans to integrate OpenXR for wider support?
For what support?
A wider support of different platforms?
Oh, I don't really know of any platforms that don't work well with it. Like, it can be a little bit tricky getting onto Android platforms that are not Quest, but it's doable. All you have to do is replace one of the files, the chips in the NuGet package. I will have more solid support for other Android systems in the future. But right now, pretty much every OpenXR platform should be doable.
Thank you. One last question, anybody? Yep, we got one more over here.
Any chance or plans of supporting WebXR as a target?
I would love to have a StereoKit running on web, and I have kind of done some explorations into this. The renderer itself does work on web and WebXR, but the C# side of StereoKits, I still need to do a little bit of extra research. When .NET 6.0 is completely released, I will probably spend some time researching into Blazor and some of that stuff, because I think this is an important place to be, and I think it's probably doable. But not yet, but hopefully soon.
Anybody else? Thank you, Nick.
All right. Thank you, everybody, for
Nick
coming.
Klingensmith. Awesome talk.